Welcome to topic 5, which is on deep reinforcement learning. Now, deep reinforcement learning is actually a different form of machine learning from what you've been talking about so far. It's not supervised learning nor unsupervised learning. It's a different version of machine learning. And we'll be talking basically about RL in general, followed by some training algorithms for RL models, and finally we'll talk about some application areas for RL. So first we want to explain a little bit more about how reinforcement learning or RL fits within the taxonomy of machine learning. So we know that actually for machine learning we have supervised learning where the data has to be labeled. Your training data must have the label so that we can actually do training using classification or regression algorithms. And then we talked about unsupervised learning where the data is unlabeled, and we also talked a little bit about semi-supervised learning where you use both labeled as well as unlabeled data for the training of a classifier. Now, reinforcement learning is actually quite different from all these three different versions of machine learning. So actually it's a different type of learning where the underlying idea for reinforcement learning is not trying to train against a particular single predicted value that we want to get as output, but we are trying to get actually a prediction for a series of actions to be taken that will actually give you the goal that you want. So there's no particular target variable to train against, nor are there raw data to train against like unsupervised learning. So what we actually want to do is basically to train against what is the best course of actions, a sequence of actions to take in order to achieve a particular goal. So here are some terms that you have to be familiar with when we talk about reinforcement learning. So first of all, the one that performs the reinforcement learning actions is what we call the agent, right? So your AI is basically the agent, and the agent will act on the environment, right? So the role of reinforcement learning is basically to determine what's the best sequence of actions, because the actions are what are the things that the agent does to the environment. Now, the environment, once it's been acted upon by the agent by a series of actions, it will actually return some feedback to the agent in two ways. One, it will actually update its state, okay, its status. So this actually, the state information will be fed back to, at time t, will be fed back to the agent so the agent knows what has changed in the environment. And it has another important hint as to whether its actions are actually optimal or not, and that's actually what I call a reward. So the environment also needs to indicate to the agent whether or not it is actually succeeding by giving it an indication of the reward. Now, if you're talking about an agent that's actually trying to control how it plays the game, this reward could be in the form of a score that you get for the game. Right? So if you get a good score, it means that you're doing the right thing in playing this game. If you get a bad score, it means that you're playing the game in a very bad manner. And you can see that there's a feedback loop that results basically the action from the agent, if it flows to the environment, and then coming back from the environment, you have a feedback in both in terms of status as well as the reward. So here are some of the definitions again. So you can the reinforcement learning can be best understood by using by focusing on the concepts of agents, environment, states, actions, and rewards. So the agent is the one that takes the action. So for example, a drone making a delivery in terms of robot is the particular character in the video game. The algorithm is the agent. Okay, so it may be useful to consider that in life the agent will be you. You are the one who acts on the environment. The actions are the set of possible moves that the agent can make, the possible set of things that the agent can do to the environment. An action is almost self-explanatory, but it should be noted that agents usually choose from a list of discrete possible actions. So in a video game, the list may include go left, go right, jump up, jump low, crouch, or stand still. In the stock market, that list of actions could be buy, could be sell, or just hold on the set of derivatives. And in the case of controlling a drone, the the actions will be actually moving at different speeds or different acceleration within the 3D space. In the environment, the world in which the agent moves, it will respond to the agent's actions. So the environment takes into account the agent's current state and action as input, and it will return as output the agent's reward and its next state. And if you are the agent, the environment could be the law. The environment could be basically the law of physics. The environment could also be the society in which you're operating that determines your actions and the consequences of them. The state is basically like a status or a concrete and immediate situation in which the agent would find itself when it has done a certain action. An instantaneous configuration that puts the agent in relation to other significant things such as tools, obstacles, enemies, and prizes. It can be the current situation returned by the environment or any future situation. Were you ever in the wrong place at the wrong time? Well, that is a state. Now, the reward is feedback that we measure in terms of success or failure of the agent's action. For example, in a video game, if Mario touches the coin, he wins points. So there's a good reward. From any given state, an agent sends output in the form of actions to the environment, and the environment returns the agent's new state as a result of his action acting on the previous state, as well as the reward, which is a feedback or nothing if there's no reward. The rewards can be immediate or delayed, and they help basically evaluate the effectiveness of the agent's actions. Now, the policy, which is something new, is the strategy that the agent can use to determine what is the next action it should take based on the reward that it's getting and based on the state. For example, example of a policy is that instead of taking the immediate reward, you may try to optimize its reward over a long period of time. That means you want to try to win overall rather than just have short-term gains. Right? So the policy maps the states to actions, the actions that promise the highest rewards. Here are some additional definitions that you should be very wary of. So the reward is being received at various points in time. Now, in order to discount the future effects, right? So let's say you are getting a very high reward at the end of the game. However, at the present moment, you need to make a decision. We will make a discount, or we create a discount so that reduce the effect of a future reward on the present, so that you will not just this is actually a factor to take into account, that the present rewards or the future rewards may not have such a significant impact at the present time. Okay, so this is actually a particular gamma value is actually to sort of discount off future rewards so that the agent will go for more short-term gains. Now, the gamma can be, of course, close to 1 so that the discount is very minimal, which means that future rewards, for example, a discount factor of 1 will make future rewards as important as immediate rewards. So we are basically trying to factor in how much delayed gratification do we want in the agent. And secondly, the trajectory is just basically the sequence of states that the agent will enter into in order to as a result of the actions that it actually takes. So the trajectory is just the path it takes through the different states that it will enter into in the environment. Now, the value that it obtains in the long run with a discount, this is basically the expected long-term return with discount as opposed to the short-term reward. R V value times the policy is the expected long-term rewards that it will gain as a result of carrying out the policy and getting rewards along the way. If we discount rewards or lower the estimated value, the further into the future they occur. So see the discount factor that we talked about earlier. In the long run, we are all dead, so that's why you should discount future rewards. So it's useful to distinguish between the two. Now, the Q value is the action value pair. So Q value is similar to value, except that it is taking an extra parameter, which is the current action. So Q pi SA refers to the long-term return of an action taken under a particular policy pi from the current state S, and Q maps the state action pairs to rewards. Note that there's a difference between the Q and the policy. So the queue maps the state action pairs, whereas the policy just determines the action that a particular agent should be carrying out. So these are some key definitions that is distinguishing between the reward is an immediate signal. So when you receive when you're in a particular state, while the value is actually the sum of all the rewards you actually get from all the intermediate states that you go through. So the value is actually the long-term expectation, while the reward is the immediate pleasure. So value is eating a spinach dinner for dinner is an anticipation of a long and healthy life, whereas the reward of eating cocaine for dinner is basically the immediate reward, and you don't care about the future. So they are basically different in the time horizon. So the value is actually the long-term reward rather than the immediate short-term reward. So you can have states where the reward and value diverge. So you might have received a low immediate reward because of eating spinach, but even as you move towards the position of higher greater gain in the long terms, or you might receive a high immediate reward such as eating cocaine, but that leads to a diminished prospect over a long time. That's why the value function rather than immediate reward is what the reinforcement learning tries to predict and control. So you actually are more interested in long-term rewards rather than just the short-term immediate reward. So the environments are the functions that transform the actions taken in the current state into the next state, and the reward are the agent's functions that transform the new state and reward into the next action. We know that, let me just repeat that. So environments are the functions that transform an action taken in the current state into the next state and a reward, whereas the agents are the functions that transform the new state and the reward into the next corresponding action. So we know that and set the agent's function, but in most situations where it's useful and interesting to apply reinforcement learning, we do not know what is actually the function of the environment. In other words, in reinforcement learning, often we really cannot control the environment. The environment just gives us back the feedback. What we can actually determine is the policy that would control the agent's function, right? How it would actually respond to the state and reward and choose the appropriate course of action. In the feedback loop above, the subscripts denote the time steps t and t plus 1. So t is the present time, t plus 1 is the next instance of time, each of which refers to different states. The state at the moment t and the state at the moment t plus 1. Unlike other forms of machine learning such as supervised and unsupervised learning, reinforcement learning can only be thought of in terms of a sequence of actions rather than just one instance in time. It's thought of as it should be thought of sequentially in terms of state action pairs, because given a certain state at a particular time, a certain action is taken on it, and that occurs one after the other. So we are coming to the end of our slides. So reinforcement learning is basically goal-oriented. In order to achieve the highest value, we are trying to learn what is the best or most optimal sequence of actions to take that will lead to the agent achieving its goal, which is to maximize the value overall. In video games, the goal or the value they're trying to achieve is basically to win the game, with the highest most points, right? So each additional point in the game will basically reinforce the agent's behavior. So the agent may soon learn that instead of trying to shoot battleships, touching coins or dodging meteors, will learn that shooting battleships, touching coins or dodging meteors would maximize its score. In the real world, the goal might be for the robot to travel from point A to point B, so every inch that the robot is able to move closer to point B would be counted like it is points. So in RL, the objective function is basically to improve the value over time. So if you're taking the sum of all the time instance from time equals to 0 to time equals to infinity, we have a summation of the reward function, and the reward function is a function of both the state x at a particular time t as well as the action that's taken at that state. So the reward is the reward that's associated with the state and the action. And the gamma is actually basically the discount factor that we have talked about earlier. So we want to sum up so that the overall improvement in the value is this, not just the return or the value at one instant time, but over the entire sequence of time steps. This is important to distinguish because you do not want the agent to just focus on near-term goals and forget about the overall or final objective that he wants to achieve. So this is like trying to kill the boss monster in the game, but it loses all health in the process of doing it and basically loses the game. So objective is to get an overall high score in the end of the game by killing as many monsters as possible, and not just kill one single monster and lose all your life trying to do it. So this is basically what the other objective function or the value enhancement is trying to do. It's trying to get the long-term maximized goal rather than just the short-term goal. So thank you for your attention. There was a lot of definitions that to go through. Further on in the next few slides, it will be more intuitive because it's important to understand the different definitions so that when we talk about the reinforcement learning training happening later, you can just refer to each of the key terms that we talked about here. So just remember the main ones will be the agent, the environment, the action, the state of the environment, and the reward that's being returned. And the difference between a reward and a value. One is the short-term immediate ones, and the other one is the overall long-term value that derives from receiving rewards at different stages. So thank you for your attention.